Welcome to the world of organic chemistry. There are very many more organic compounds than anything else. And what makes something organic is that it contains carbon. So, organic chemistry, it's all about carbon and what carbon can do. So we're going to see carbon with hydrogen, which are called hydrocarbons, and that's what we're going to start with. We're also going to see oxygen, nitrogen, sulfur, phosphorus, and the halogens added to them in other sessions. We're going to see lots of different variations, and the reason we see so many variations is because the bonding in hydrocarbons are all based on the fact that carbon has 4 valence electrons and can form 4 bonds. So if carbon has 4 valence electrons, carbon can form 4 single bonds. It can form 1 double bond and 2 single bonds. It could form 2 double bonds. It could form a triple bond and a single bond. And it can keep linking and make really big molecules, really long chains. Now these bonds that are forming are covalent bonds, which covalent bonds mean sharing electrons. So, if we're just looking at the bond between carbon and hydrogen, those two can be shared. So carbon would be bonded to the hydrogen, and then there's still 4 other bonds to be bonded to whatever. Organic compounds tend to have low melting and boiling points. So we're going to see some liquids and gases at room temperature. They burn. So we're going to be looking at combustion reactions. Most of them are nonpolar. So if they are nonpolar, they are not soluble in water. They would be soluble in nonpolar solvents. And we can get really, really big molecules. So since we're getting larger molecules here, we need to look at more than just the molecular formula. Now, the molecular formula is where we need to start, but all it shows us is the number and type of atoms. So we've got 3 carbons and 8 hydrogens here, but we don't know at all how they are connected. So if we do the complete or expanded structural formula, we've got 3 carbons connected with single bonds. And each of them must have 4 bonds. So our hydrogens are round like that. And that is a complete or expanded structural formula. It shows everything. Now, we don't usually write that. We usually write a condensed structural formula, which essentially what it does is it abbreviates the hydrogens. So we just do each carbon and its hydrogens as a little condensed chunk.